Good afternoon everyone. My name is T. Sunita from CSCE department. Today I am going to explain about the topic is the free radicals of mechanism of PVC. PVC is nothing but an polyvinyl chloride. What is polyvinyl chloride means? It is one of the world's most versatile and widely used plastics from pipes to packaging. This presentation explains how it's made. Let's see the building block. Vinyl chloride. Vinyl chloride chemical name is chloroethene. Formula of vinyl chloride is C2H3Cl or CH2CHCl. Key feature is a carbon-carbon double bond that can be opened by a free radical. Process. Thousands of these monomer units are linked together in a chain reaction to form the final polymer. The mechanism is in three steps: initiation, propagation and termination. An initiation molecule creates the first active free radical which then attacks a monomer to start the chain. Propagation. The active chain rapidly adds thousands of monomer units one after another, growing the polymer. And third one is termination. Two growing chains react with each other, neutralizing their radical ends and stopping the reaction, forming the final dead polymer. Step 1. Initiation. The process kicks off with an initiator like benzoyl peroxide or AIBN. Heat causes the initiator to split apart homolytic cleavage, forming two highly reactive free radicals R dot. This initiator radical attacks the double bond of a vinyl chloride monomer, adding to it and transferring the radical to the monomer. This chain has now begun. Propagation. Step 2. This is the main chain building step. The active monomer radical from the initiation step attacks the double bond of another vinyl chloride monomer. The monomer is added to the chain and the radical moves towards the newly added unit. This process repeats thousands of times and creating a long growing and micro radical at very high speed. The vast majority of monomer is consumed in this step. Step 3. Termination. Recombination means coupling. Two growing micro radicals P dot find each other and their radicals ends combine to form a single stable and covalent bonds. This results in one long dead polymer chain. Disproportionation. One growing radical steals a hydrogen atom from its neighbor. This results in two dead chains, one saturated normal and with one C double bond at its end. Beyond the basics, chain transfers. The critical side reaction that defines PVC structures. Chain transfer to monomer. A growing polymer radical P dot can steal a hydrogen or chlorine atom from a monomer molecule. This terminates the growing chain. It becomes dead and creates a new smaller monomer radical M dot. This new monomer radical then starts a new polymer chain. This is the main reaction that limits the final molecular weight. Chain length of PVC. PVC is nothing but a polyvinyl chloride. Chain transfer to polymer. A growing radical P dot can also steal an hydrogen atom from the backbone of existing finished polymer chain. This creates a new radical in the middle of the finished chain. This new backbone radical can now add monomer propagation, creating a branch. This is why PVC is a branched polymer which affects its physical properties. The final PVC structure. Primarily head to tail. Monomers are mostly linked in a regular CH2CHCl pattern. Branched of PVC structure. Chain transfer to the polymer backbone creates significant branching. Actic. The chlorine atoms are arranged randomly along the chain, not in a regular repeating pattern, which makes PVC an amorphous, non-crystalline material. Defect structures. Some head-to-head linkages and unsaturated ends from termination exist, which can be points to weakness. Thank you. Thank you for giving this opportunity. Thank you.